Hi students, welcome back to JP Physics Academy. This is Naresh Babu Jawaji. Students, in the last video we discussed the concepts of dimensions and dimensional formulas. Today we are going to discuss about the new concept, that is the uses of the dimensional formulas. Okay students, before we go to that video, let me tell you a small thing. Students, don't skip the video from beginning to ending, because of today I'm going to frame that video somewhat lengthy, means for a few minutes lengthy than the previous videos. So it is very important concept for that MSET and remaining all the competitive examinations, means all the entrance examinations. That's why I want to make the somewhat lengthy video. I want to give the brief information about these concepts. That's why I made that the lengthy video. That's why please don't skip the video from beginning to ending. Okay, let's go to the video, students. Principle of homogeneity. First concept is principle of homogeneity. Because of whatever the advantages of the dimensions and dimensional formulas, all of them which can be explained by the basis of this principle of homogeneity. First of all, let us try to know what is meant by principle of the homogeneity. So principle of the homogeneity means here the terms on, for suppose there is a dimensional equation, the dimensional equation is there, for suppose on this, in this dimensional equation, then both sides of the dimensional equations should have the same dimensions. That is the main concept of the principle of homogeneity. For suppose students, here formula, according to the Newton's second law, there is a formula F is equals to ma. This is the force formula. F is equals to ma, means force is defined as the product of mass and acceleration. This is a simple definition of the force. Okay, then let us try to know about the principle of homogeneity. What does it mean? So principle of homogeneity means this is the general formula. This is a general formula. What is the dimensional formula of the force? M1 L1 T minus 2, that is equals to, what is the dimensional formula of the mass? M1. At the same time, what is the dimensional formula of the acceleration? L1 T minus 2. So students, this we are calling as dimensional equation. The dimensional equation. In this dimensional equation, on both side terms which are having the same dimensions. In the case of mass, in the left hand side of this equation of the dimensional formulas. So in the power, what is the dimension of mass in the left hand side? 1 plus 1. In the right hand side also plus 1. What is the dimension in the left hand side of the expression? Plus 1. What is the dimension of the length in the right hand side? Plus 1. So here the time also same dimensions. Means in the dimensional equation, on both sides, and the terms on both sides in the dimensional equation which are having the same dimension, that we are calling as principle of homogeneity. Students, once again, on both terms, on terms of both sides, the terms on both sides in the dimensional equation which should have the same dimension, same dimensions, then we call this expression as a principle of homogeneity. Is it clear, students? Then based on this principle of homogeneity, based on this principle of homogeneity, we can try to understand that advantages of the dimensional formulas. Okay, so what is the statement of this principle of homogeneity? The statement is the terms on both sides, of dimensional equation should have same dimensions. So this is the statement of the principle of the homogeneity. So the statement of the principle of homogeneity is, in this expression, in this dimensional equation, whatever the terms are there, all terms should have that same dimensions on both sides of the equality. Is it clear, friends? Now let's go to discuss about the next concept. Means applications. Nothing but the advantages only. Applications of Applications of dimensional formulas. Dimensional formula. Okay, applications of dimensional formula. What are the advantages? What are the applications of this dimensional formula? Let us discuss each and everything by the good example. Okay, right. So first application of this dimensional formula is to change the unit from one system to another system. One system to another system. Okay, students, what does it mean to change the unit from one system to another system? Means for suppose the value was given in MK system, if you want to change it into the CJ system, so by use this dimensional formula, we can change that value from one system to another system. Means from MK system to CJ system, or from CJ system to MK system, the value can be changed by use this dimensional formulas. How do we change these dimensional formulas from one system to another system? Let us discuss later. Okay. So second application of this dimensional formula is to correctness of, or to check the correctness of the dimensional equation. Dimensional equation. Okay, dimensional equation means whatever the expression is there, whether it is right or wrong, it is correct or wrong, we can check by use this dimensional formulas. How do we check it? How do we describe that? How do we derive that expression? Let us discuss now only. The most important, the third application of the dimensional formula is to derive the relationship between any physical quantities. Means, what does it means to derive the relationship between any physical quantities? Means we can derive the formula, we can derive the expression which is particular, which is corresponding, which is the respect to the physical quantity. For suppose students, if you find out the formula of the speed, v is equals to the rate of distance, or the v is equal to s by t. So if you want to derive this expression by use this dimensional formula, we can derive the expression also. That is the meaning of this third statement. Okay. So once again, by use this, the applications of the dimensional formulas is, first one is we can change the unit from one system to another system. That is first application. And second one is whatever the expression is there, whatever the formula is there, whether it is correct or wrong, we can decide. We can change. We can observe that one by use this dimensional formulas. And third one is to derive. We can derive any expression. To derive that any expression or relation among the more than one quantities are there, we can find out the relationship between that any physical quantities. These are the applications of the dimensional formulas. Students, let us try to know that each and everything by use a single example. Okay. First of all, let us try to know the first application of the dimensional formulas, that is to change the unit from one system to another system. So in this case, our aim is we have to change the value of any physical quantity from one unit to another unit, from one system to another system. So students, for suppose there is a dimensional formula of the physical quantity, let it be as MA, LB and TC. Actually, generally we can express the dimensional formula of any physical quantity in terms of mLT, Ki, okay, and mole and candle, CD, okay, and based on this basis physical quantity means fundamental physical quantities only. So most of the physical quantities dimensional formula can be ending by this mLT only, okay na? So let us try to know the complete information by use this mLT only, okay na? Then let us be the dimensional formula. The dimensional formula of a physical quantity is MALBTC. Okay now. And the numerical value of the physical quantity, let it be as the N1. After this is the, for suppose M case the replace before we convert the value, before we convert the given value, this is a numerical value for suppose. Then after that, the units of these quantities are M1, L1, T1. After which convert the value, after we change this value, after we change this given value in the another system, the let it be as the numerical value is N2, and after we convert the values, the units are M2, L2 and T2. Okay students, so once again here we are considering a dimensional formula because MALBTC, I am not giving the specific values of the dimensions, and because of this can be useful for every physical quantity, that's why it is the general form of the dimensional formula. Then MALBTC is the dimensional formula, and N1 is the before we change the system, that is the numerical value N1. Then M1, L1, T1 are the units of the given physical quantities, okay, given fundamental physical quantities, and N2 is the after we change the system, the numerical value N2, and M2, L2, T2 are the units of the physical quantities after we convert the system. Okay na? Let us try to know the complete information about this units from one system to another system with an example. For suppose there is an example, for suppose work is there. What is the general formula of the work? Force into distance. Force into distance is the general formula. Means W is equal to Fs. Then what is the dimensional formula of the work? That is equal to force means M1, L1, T minus 2 into distance means what is the dimensional formula of the distance? L1. So finally the dimensional formula of the work is M1, L2 and T minus 2. This is the dimensional formula of the work. After that, so in this case, for suppose the 1 joule is equals to how many ergs? How many ergs means how many means that is represented by N. We don't know what is the value of the 1 joule is equal to how many ergs. Okay now, let us find out. Means joule is the MKS unit of the work and erg is the CGS unit of the work. Are you following students? Joule is the MKS unit of the work and erg is the CGS unit of the work. Means what does it means? 1 joule is equals to how many ergs? That is the question. Okay students. Now let us find out the value of this value of this N by use this dimensional formulas. Okay. Then what is that? Then N is equal, how do we write this one? 1 joule per erg. Here 1 joule is equal to n ergs. We are finding the N value. That's why N is equals to 1 joule per erg. Means we are converting from joule MK system to erg CJ system. Then N is equals to M1 by M2 A and L1 by L2 B and T1 by T2 C. Because of students here, how do we write this expression? N1 into M1A L1B T1C is equals to N2 into M1 M2A L2B and T2C. So if you want to find any value, then N1 is equals to N2 into M2 by M1 A L2 by L1 B T2 by T1 C. This is by use this formula we can find out that any value of the any physical quantity. Okay na? Just we are doing like this. So N is equals to student, let us consider these numerator values in this expression. The M1, L1, T1 belongs to the SI system values. Sorry. And M2, L2, T2 are the D2 belongs to the CGS system values. Okay students, M1 what is m1 here actually? The unit of mass in MK system. What is the unit of mass in MK system? Kilogram by. This M2 is the unit of mass in CJ system. That is, what is the CJ's unit of the mass? Gram into per. What is the A? What is the A here? A means that the dimension of mass in the work. What is the dimension of work? Dimension of mass in work plus 1. After that, L1 by L2. L1 means the MKS unit of the length is meters by what is the CJ's unit of the length? Centimeters. Or what is the dimension of length? What is the dimension of length in work? 2 plus 2 by into what is the MKS unit of the time? Second by what is the CJ's unit of the time? Second for minus 2. What is the C value? So what is the dimension of the time in the work? Minus 2. Minus 2. So after that, N is equals to. So let us convert this value from kilograms to grams. Because of our aim is we have to find out the value from joules to kilogram. Okay now, we have to find the N value means 1 joule is equal to how many ergs. 1 joule is equals to how many ergs. That's why kilograms to grams means let us convert this value from MK system to CJ system. 1 kilogram is equals to 1000 gram per 1 gram as this. Okay, power 1 into 1 meter is equal to how many centimeters? 100 centimeters divided by centimeters as usual. Whole power 2 plus 2 is the dimension plus 2 is there into 1 second. Second gets cancelled. 1 power means a constant value is there. 1 power minus 2. Then N is equals to this gram gets cancelled. The centimeters gets cancelled. What is the remaining here? 1000 by 1 means that 10 cube here. 10 cube power 1 and this centimeters gets cancelled. What is the remaining here? 100 means 10 square. What is of its dimensionality? Square. And 1 power minus 2 is always be 1 only. Okay? Then N is equals to 10 cube into 10 square whole square means that 10 power 4. Then N is equals to 10 cube into 10 power 4 is equals to 10 power 7. Means here what you got the N value? What you got the N value? 1 joule is equals to 10 power 7 ergs. So this is the method to find the values of any system. Okay students. So this is a method to derive that expression. This is a method to find out the value, a numerical value of that any physical quantity from one system to another system. Is it clear students? Right. Means 1 joule is equals to 10 power 7 ergs. Okay students, we completed to know about the first application of the dimensional formulas, that is to change the units of any physical quantity from one system to another system by use the dimensional formulas. Okay students, then next video we go to discuss about the remaining two applications with good examples. Okay students, this is the end of today's class. If you like this video, please like and please like this video, comment on this video and please share this video and don't forget to subscribe our channel and please click on the bell and for getting the first notification. Okay students, this is the end of today's class. Meet again tomorrow. Have a great day. Bye.